1926 Subpart P Appendix A. Soil Classification. Scope and Application. Scope. This appendix describes a method of classifying soil and rock deposits based on site and environmental conditions, and on the structure and composition of the earth deposits. The appendix contains definitions, sets forth requirements, and describes acceptable visual and manual tests for use in classifying soils. 2. Application. This appendix applies when a sloping or benching system is designed in accordance with the requirements set forth in Section 1926.652, b. 2, as a method of protection for employees from cave-ins. This appendix also applies when timber shoring for excavations is designed as a method of protection from cave-ins in accordance with Appendix C to Subpart P of Part 1926, and when aluminum hydraulic shoring is designed in accordance with Appendix D. This appendix also applies if other protective systems are designed and selected for use from data prepared in accordance with the requirements set forth in Section 1926.652c, and the use of the data is predicated on the use of the soil classification system set forth in this appendix. B. Definitions. The definitions and examples given below are based on, in whole or in part, the following: American Society for Testing Materials, ASTM, Standards D653, 85 and D2488, the Unified Soils Classification System, the US. Department of Agriculture, USDA, Textural Classification Scheme, and the National Bureau of Standards Report BSS 121. Cemented soil means a soil in which the particles are held together by a chemical agent, such as calcium carbonate, such that a hand-size sample cannot be crushed into powder or individual soil particles by finger pressure. Cohesive soil means clay, fine-grained soil, or soil with a high clay content, which has cohesive strength. Cohesive soil does not crumble, can be excavated with vertical side slopes, and is plastic when moist. Cohesive soil is hard to break up when dry, and exhibits significant cohesion when submerged. Cohesive soils include clayey silt, sandy clay, silty clay, clay, and organic clay. Dry soil means soil that does not exhibit visible signs of moisture content. Fissured means a soil material that has a tendency to break along definite planes of fracture with little resistance, or a material that exhibits open cracks, such as tension cracks, in an exposed surface. Granular soil means gravel, sand, or silt, coarse-grained soil, with little or no clay content. Granular soil has no cohesive strength. Some moist granular soils exhibit apparent cohesion. Granular soil cannot be molded when moist and crumbles easily when dry. Layered system means two or more distinctly different soil or rock types arranged in layers. Micaceous seams or weakened planes in rock or shale are considered layered. Moist soil means a condition in which a soil looks and feels damp. Moist cohesive soil can easily be shaped into a ball and rolled into small diameter threads before crumbling. Moist granular soil that contains some cohesive material will exhibit signs of cohesion between particles. Plastic means a property of a soil which allows the soil to be deformed or molded without cracking, or appreciable volume change. Saturated soil means a soil in which the voids are filled with water. Saturation does not require flow. Saturation, or near saturation, is necessary for the proper use of instruments such as a pocket penetrometer or shear vane. Soil classification system means, for the purpose of this subpart, a method of categorizing soil and rock deposits in a hierarchy of stable rock, type A, type B, and type C, in decreasing order of stability. The categories are determined based on an analysis of the properties and performance characteristics of the deposits and the environmental conditions of exposure. Stable rock means natural solid mineral matter that can be excavated with vertical sides and remain intact while exposed. Submerged soil means soil which is underwater or is free seeping. Type A means cohesive soils with an unconfined compressive strength of 1.5 ton per square foot, TSF, 144 kilopascals, or greater. Examples of cohesive soils are clay, silty clay, sandy clay, clay loam, and, in some cases, silty clay loam and sandy clay loam. Cemented soils such as caliche and hardpan are also considered type A. However, no soil is type A if I. The soil is fissured, or 2. The soil is subject to vibration from heavy traffic, pile driving, or similar effects. or 3. The soil has been previously disturbed, or 4. The soil is part of a sloped, layered system where the layers dip into the excavation on a slope of 4 horizontal to 1 vertical, 4h, 1v, or greater, or v. The material is subject to other factors that would require it to be classified as a less stable material. Type B means I. Cohesive soil with an unconfined compressive strength greater than 0.5 tsf, 48 kilopascals, but less than 1.5 tsf, 144 kilopascals, or 2. Granular cohesionless soils including angular gravel, similar to crushed rock, silt loam, sandy loam, and, in some cases, silty clay loam and sandy clay loam. 3. Previously disturbed soils except those which would otherwise be classified as type C soil. 4. Soil that meets the unconfined compressive strength or cementation requirements for type A, but is fissured or subject to vibration, or v. Dry rock that is not stable, or 6. Material that is part of a sloped, layered system where the layers dip into the excavation on a slope less steep than 4 horizontal to 1 vertical, 4h, 1v, but only if the material would otherwise be classified as type B. Type C means I. Cohesive soil with an unconfined compressive strength of 0.5 tsf, 48 kilopascals, or less, or 2. Granular soils including gravel, sand, and loamy sand, or 3. Submerged soil or soil from which water is freely seeping, or 4. Submerged rock that is not stable, or the material in a sloped, layered system where the layers dip into the excavation on a slope of 4 horizontal to 1 vertical, 4h, 1v, or steeper. Unconfined compressive strength means the load per unit area at which a soil will fail in compression. It can be determined by laboratory testing, or estimated in the field using a pocket penetrometer, by thumb penetration tests, and other methods. Wet soil means soil that contains significantly more moisture than moist soil, but in such a range of values that cohesive material will slump or begin to flow when vibrated. Granular material that would exhibit cohesive properties when moist will lose those cohesive properties when wet. C. Requirements. Classification of soil and rock deposits. Each soil and rock deposit shall be classified by a competent person as stable rock, type A, type B, or type C in accordance with the definitions set forth in paragraph B of this appendix. 2. Basis of classification. The classification of the deposits shall be made based on the results of at least one visual and at least one manual analysis. Such analyses shall be conducted by a competent person using tests described in paragraph D below, or in other recognized methods of soil classification and testing such as those adopted by the American Society for Testing Materials, or the U.S. Department of Agriculture Textural Classification System. 3. Visual and manual analyses. The visual and manual analyses, such as those noted as being acceptable in paragraph D of this appendix, shall be designed and conducted to provide sufficient quantitative and qualitative information as may be necessary to identify properly the properties, factors, and conditions affecting the classification of the deposits. 4. Layered systems. In a layered system, the system shall be classified in accordance with its weakest layer. However, each layer may be classified individually where a more stable layer lies under a less stable layer. 5. Reclassification. If, after classifying a deposit, the properties, factors, or conditions affecting its classification change in any way, the changes shall be evaluated by a competent person. The deposit shall be reclassified as necessary to reflect the changed circumstances. D. Acceptable visual and manual tests. Visual tests. Visual analysis is conducted to determine qualitative information regarding the excavation site in general, the soil adjacent to the excavation, the soil forming the sides of the open excavation, and the soil taken as samples from excavated material. Observe samples of soil that are excavated and soil in the sides of the excavation. Estimate the range of particle sizes and the relative amounts of the particle sizes. Soil that is primarily composed of fine-grained material is cohesive material. Soil composed primarily of coarse-grained sand or gravel is granular material. 2. Observe soil as it is excavated. Soil that remains in clumps when excavated is cohesive. Soil that breaks up easily and does not stay in clumps is granular. 3. Observe the site of the opened excavation and the surface area adjacent to the excavation. Crack-like openings such as tension cracks could indicate fissured material. If chunks of soil fall off a vertical side, the soil could be fissured. Small spalls are evidence of moving ground and are indications of potentially hazardous situations. 4. Observe the area adjacent to the excavation and the excavation itself for evidence of existing utility and other underground structures, and D. To identify previously disturbed soil. V. Observe the open side of the excavation to identify layered systems. Examine layered systems to identify if the layers slope toward the excavation. Estimate the degree of slope of the layers. 6. Observe the area adjacent to the excavation and the sides of the opened excavation for evidence of surface water, water seeping from the sides of the excavation, or the location of the level of the water table. 7. Observe the area adjacent to the excavation and the area within the excavation for sources of vibration that may affect the stability of the excavation face. 2. Manual tests. Manual analysis of soil samples is conducted to determine quantitative as well as qualitative properties of soil and to provide more information in order to classify soil properly. Plasticity. Mold a moist or wet sample of soil into a ball and attempt to roll it into threads as thin as 1/8 inch in diameter. Cohesive material can be successfully rolled into threads without crumbling. For example, if at least a 2-inch 50 mm length of 1/8 inch thread can be held on one end without tearing, the soil is cohesive. 2. Dry strength. If the soil is dry and crumbles on its own or with moderate pressure into individual grains or fine powder, it is granular, any combination of gravel, sand, or silt. If the soil is dry and falls into clumps which break up into smaller clumps, but the smaller clumps can only be broken up with difficulty, it may be clay in any combination with gravel, sand, or silt. If the dry soil breaks into clumps which do not break up into small clumps and which can only be broken with difficulty, and there is no visual indication the soil is fissured, the soil may be considered unfissured. 3. Thumb penetration. The thumb penetration test can be used to estimate the unconfined compressive strength of cohesive soils. This test is based on the thumb penetration test described in American Society for Testing and Materials, ASTM, Standard Designation D2488, Standard Recommended Practice for Description of Soils, Visual Manual Procedure. Type A soils with an unconfined compressive strength of 1.5 tsf can be readily indented by the thumb, however, they can be penetrated by the thumb only with very great effort. Type C soils with an unconfined compressive strength of 0.5 tsf can be easily penetrated several inches by the thumb, and can be molded by light finger pressure. This test should be conducted on an undisturbed soil sample, such as a large clump of spoil, as soon as practicable after excavation to keep to a minimum the effects of exposure to drying influences. If the excavation is later exposed to wetting influences, rain, flooding, the classification of the soil must be changed accordingly. 4. Other strength tests. Estimates of unconfined compressive strength of soils can also be obtained by use of a pocket penetrometer or by using a hand-operated shear vane. V. Drying test. The basic purpose of the drying test is to differentiate between cohesive material with fissures, unfissured cohesive material, and granular material. The procedure for the drying test involves drying a sample of soil that is approximately 1 inch thick, 2.54 centimeters, and 6 inches, 15.24 centimeters in diameter until it is thoroughly dry. If the sample develops cracks as it dries, significant fissures are indicated. B. Samples that dry without cracking are to be broken by hand. If considerable force is necessary to break a sample, the soil has significant cohesive material content. The soil can be classified as an unfissured cohesive material and the unconfined compressive strength should be determined. C. If a sample breaks easily by hand, it is either a fissured cohesive material or a granular material. To distinguish between the two, pulverize the dried clumps of the sample by hand or by stepping on them. If the clumps do not pulverize easily, the material is cohesive with fissures. If they pulverize easily into very small fragments, the material is granular.